Hi everyone! In this video, I will first tell you a little about the environment of the Jupyter Notebook. I will then explain how the Python code of two functions in Jupyter Notepad works. Let's just begin. Jupyter Notebook is a web-based editor. Jupyter Notebook is often used in data analysis with Python. When we run Jupyter Notebook, it opens our computer with a predefined web browser. When we first open it, we encounter such a screen. Here we see the files and folders on our computer. We choose the folder we want and we click the New button and we choose Python 3. Our Jupyter Notebook page opens. Jupyter Notebook files have an IPYNB extension. We can rename the work from the rename part. I'm writing YouTube. We can write and execute our code in these lines. We can run it by pressing the Run button or pressing the Ctrl plus Enter buttons. For example, let's write Hello World and run it. I'm writing print Hello World and run it. Each of these lines in which we write code is a called cell. We can click the plus button to add cells and click the scissors buttons to cut cells. Thanks to these arrows, we can navigate between the cells, so we can do operations on the cells from here. Let me tell you about the menu. From the File menu, we can open a new notebook by clicking the New Notebook button and then the Python 3 button. By clicking on the Open button, we can open one of the existing notebooks. We can create a copy of the notebook by clicking the Make a Copy button. We can do these and file operations such as saving, renaming from the File menu. From the Edit menu, we can perform operations related to the cell. We can perform operations such as cutting, copying and deleting a cell, or we can retrieve the deleted cell. From the View menu, we can remove or restore titles, toolbars and line numbers. For example, I remove line numbers and return them. And the toolbar in the same way. In the Insert menu, we can add new cells above or below the cells. We can execute code from the Cell menu. We can do operations such as run cells and select below, run cells and insert below, or run all. From the Kernel menu, we can perform operations related to the workspace. For example, we can stop the codes that we run with interrupt. We can run it again with restart. With restart and clear output, we can clean all outputs and run again. We can save new widgets from the widget menu and delete widgets. There are two modes here, edit mode and comment mode. When we are in the cell, we are in edit mode. In edit mode, there is a pen symbol here. With the ESC button, we can switch to comment mode. In the help menu, we can learn shortcuts in edit mode and comment mode with keyboard shortcuts. Now let's move on to the first function, perfect numbers. First, I want to define perfect numbers. In number theory, a perfect number is a positive integer that is equal to the sum of its positive divisors except for the number itself. Here we see the examples of perfect numbers. For instance, 6 has divisors 1, 2 and 3 excluding itself, and 1 plus 2 plus 3 equals 6. So 6 is a perfect number. And there are many more perfect numbers. Let's move on to how the code works. First, we define a function called perfect number using def. This function will take a parameter named number. Here we create a variable named total to hold the integer divisors of the number. We equate it to 0. To find integer divisors of a number, we need a for loop. The loop will start at 1 and end at number. Here, the numbers in which the number is exactly divided will be added to the total variable, and we are out of the loop. Through the loop, we found the sum of integer divisors other than the number itself. Now we use the if-else block. If the total variable is equal to the number, the function will say the number is a perfect number. If it is not equal, the function will say the number is not a perfect number. We have come to the end of the function. Now we ask the user to enter a number. We equalize this number to the number variable, and finally we call the function. We send the number we receive from the user to the function as a parameter. And let's run the code and see. Let's try the number on the side. I'm writing 496, and the correct results, I'm writing 28, and correct results, I will write 6, and it's true. Let's try numbers that aren't perfect. I'm writing 5, correct results, and I'm writing 32, it's correct results. So we found that the code worked correctly. Let's move on the other function. Amicable numbers. I want to define amicable numbers. Amicable numbers are two different numbers related in a such way that the sum of the proper divisors of each is equal to the other numbers. Here we see examples of amicable numbers. The smallest pair of amicable numbers is 220, 284. They are amicable because the proper divisors of 220 are 1, 2, 4, 5, 10, 11, 20, 22, 44, 55, and 110, which is the sum of 284. And the proper divisors of 284 are 1, 2, 4, 71, and 142, which is the sum of 220. And let's move on to how the code works. First, we define a function called amicable number using def. This function will take two parameters. These parameters are number 1 and number 2. Here we create a variable named sum1 to hold the integer divisors of number 1, and a variable named sum2 to hold the integer divisors of number 2, and we equate them to 0. To find sum1 and sum2, we need two for loops. The first cycle will start at 1 and end at number 1. The second cycle will start at 1 and end at number 2. In the first loop, the numbers exactly divided by number 1 will be added to sum 1. In the second loop, the numbers exactly divided by number 2 will be added to sum 2. And when the cycles end, we find sum 1 and sum 2. Now we will use the if-else block. If the sum 1 is equal to number 2 and sum 2 is equal to number 1, the function will say amicable numbers. If they are not equal, the function will say that they are not amicable numbers. We have come to the end of the function. Now we ask the user to enter the first number, and we equate this number to the first number variable, and we ask the user to enter the second number, and we equate this number to the second number variable. We call the function. We send the numbers we receive from the user to function as parameters. Let's run the code and see. We can use the example amicable numbers on the side. I'm writing 220 for the first number. I'm writing 284 for the second number. The function should say that they are amicable numbers. I'm running and correct results. Let's try another pair of numbers. The first number is 2620. The second number is 2924. These are amicable numbers and I am running. And the correct results. Let's try non-amicable numbers. I'm writing 550 for the first number. I'm writing 220 for the second number. These are not amicable numbers and I'm running. And the correct results. I'm writing 5 for the first number and 20 for the second number. These are not amicable numbers and I'm running. And the correct results. So we came to the end of the video. Thank you so much for watching. Goodbye.